Hello everybody, welcome back to our Windows series. This session is a little different than the other ones. What I hope to cover here is information for you as a professional to take with you to the field. If your responsibility is to make sure that a window installation goes properly from beginning to end, this information that we're going to go over today will help you identify proper window installation procedure, materials, and all the things and considerations that need to happen for that process to go well. When you're on site, it might be up to you, it might be your responsibility to point out problems or issues for that successful installation. And let me tell you, windows are complicated building components. We need to have every step of the way needs to go well, and that's either for that window to work properly, to fit in the opening properly, or for it to be airtight or watertight. So let's go ahead and get into some of these details. Let's start this conversation off with our rough opening. There are three things that we're concerned about with our rough opening when we're installing a window. One is our size, two is how square is that rough opening, and three is how level and plumb is it. So starting with our size, the rough opening typically should be a 1/2 inch taller and a 1/2 inch wider than our window. That gives us a 1/4 inch gap to work with to make some adjustments in that window as we install it. When we come to our squareness of that window, this helps too. If our window's out of square, it doesn't matter if it's oversized. It needs to be the same shape as the window. Windows are made square. The rough opening has to be square. We can check that in a number of ways. We can measure our diagonals. Those should be equal. That will tell us that that rough opening is square. If it's a small enough rough opening, we could use a framing square to check those 90-degree corners. Our third condition for that rough opening is how level and plumb is it. Our base or our bottom of our rough opening should be level, and our sides should be plumb. The top should be level as well. And if it's square and the sill is level, chances are all the other sides will work. It does not hurt to check these things though. So if you're on site, you have a question, have a level with you. It's an easy and quick check. It doesn't have to be a super long level one just to get a baseline check on it. And keep in mind, we call this a rough opening for a reason. It's not a perfect measurement we're going to get here, but if you check your height from left to right on your rough opening and you're out a 1/2 inch, say, you know you've got a problem. We only have a 1/2 inch of play from our actual window size to our rough opening size, so that would have to be corrected before we even attempted to install that window. If you're out by 1/8 inch, not that big of a deal. Remember, we have that extra room that we can adjust that window in that rough opening. If you're a building professional, say a construction manager or someone that's in charge of this window installation process, make sure that you're checking or verifying the size of your windows, and then check your rough openings to make sure that those will fit. You might have a whole house full that could be 20 windows, and it could go really wrong if somebody did not read the plans or that the rough openings are not quite square or to size. The next topic for window installation to cover here is shims. We use shims a lot when we're building. They're very important for especially windows to support it on the sill. I've seen window installations without shims, and you're asking for trouble for a lot of reasons. Number one is we want to center that window in our rough opening. This 1/4 inch gap all the way around cannot be achieved if we set that window directly on the sill. So the shims help raise that window up. It's going to support that window. The next benefit of shims is structural support. A lot of installation instructions point out or they spec out shims in specific places on the window, especially if you're using vinyl windows. Vinyl tends to flex a lot, and without the shims, the frame of that window cannot stay straight or square. So shims will also help us keep that window straight in that rough opening, especially on the sill where a lot of your weight of that window is bearing on those particular points. Typically they go on the outside corners left and right of your rough opening. And if you have a mullion, this also will carry a lot of weight of that window. That will also expect to be supported. If you see a window in a rough opening, especially on the bottom, and you see a bow to it, it means that the weight of the window or there's a flex to the window that's not being supported. Chances are that is a location that did not receive shims that needed it. You might ask, if a window needs support, why not set it directly on the sill so it gets full bearing all the way across? We need to, number one, we need to center this window in that opening. We need the gap, and we're going to fill this gap with a foam later. So that condition of the window directly on the sill just doesn't work. There's another reason for shims also, and that will be to adjust the window as we work up the sides. And the shims will help shift that window once we lock the bottom in place, hopefully maybe to square or adjust that window to make it more true so that it works better. You should never see a shim on the top edge of a window between the rough opening and that window unit. This is a big no-no. Same with doors. Your header should be clear and free to move, and it should never bear on your window unit. It's best practice to always check manufacturer's instructions for whatever specific window unit you're putting in. This information will change from model to model, from manufacturer to manufacturer. You have to look at the instructions, and it's always spelled out in great detail, whether it's the type of fasteners, type of shims, locations of shims, all of the dimensions. All of these details are very specific, and the manufacturer does this for a reason. So we've been through the rough opening and window sizing. We've talked about setting the window and shimming and adjusting that window. If all that's done right, the window should operate. And an easy way to check a window to see if it's put in right is to operate that window. So I have a window installed here, and I can open and close the movable sashes on this window. And if it happens easily, it should be a minimal effort to open and close it, to lock it. And if you see problems with the way the window fits in the frame, this is going to tell you that there's a problem somewhere with how that window was installed. This is a good time to pull out a level and a tape measure. Check your window for square, right, with our diagonals like we talked about. Those should be equal. You can even use a level on the window to see if it was set level in Plumb. This, you're the investigator. This will help you determine what is the problem with this window, if there is one, to help pinpoint where things went wrong. So since I'm here, let's go ahead and talk about fasteners. And almost all windows, especially ones with nailing fins or flanges, will have fasteners in them. We need a lot of fasteners to put a window up, and there should be several fasteners all the way around. They will have specific spacing on the perimeter, and they will, according to the manufacturer, they will give specific specs to stay off of the corners a certain distance. Make sure that you know what those two specs are. Every set of instructions or installation instructions that I've seen for windows calls that out, and there's a reason for that. If we get a fastener too close to a corner, it tends to warp the frame and mess with the unit. And so we stay off. This particular window, it said 3 inches from the corner. And we also have to use the pre-stamped slots that are in this flange. The other spec that they call out is a spacing all along the perimeter. It's interesting because this manufacturer spelled out a specific spacing of 7 inches max for the perimeter fasteners. Well, my holes are set at 4 inches. So I couldn't skip any holes. That would put me at 8 inches, which is out of my spec. So we're putting in more fasteners, one every 4 inches. So you have to not only look at the spec, but then measure your slots or holes and then figure out what keeps you within the parameters that they're giving you. So all of this comes into play, and your installation crew needs to understand these things because they affect the way the window stays true, how it seals to the building, and how it keeps it operational. So along the lines of the instructions or specs from the manufacturer, they often spell out more than one fastener that's approved for this installation. Generally, they will give you a screw or a nail option, and they will even get into the sizing of those as far as the length of those fasteners. Here we've used a modified truss head screw. I've also seen roofing nails spec'd, and this particular set of instructions gave either option, both as a 2-inch length for the fastener. So we've talked about how the window fits, how we will install it to keep it true and square. Now it's about sealing the window. This has to do with how we deal with the house wrap. We're caulking the window into place. We need a sill pan at the bottom, and we also need flashing around that window to seal it up as well. So starting with the rough opening and the house wrap, it has to be cut in a specific way. We're going to use an eye cut, and we did that in the installation. You can see the cuts that you have to make will be flush with the top and the bottom of the rough opening, and then we're going to cut down the middle. All this gets wrapped in, and the purpose, we're trying to make this watertight. It starts with our house wrap, and then all of the parts will get added in. So the only difference that you'll see, or a variation of this house wrap, would be how it wraps in on the sides. And we cut it right in the center of the sides of the rough opening. You might see that wrapped all the way in. I've actually seen the sides cut flush. This, or the attitudes about that specific cut, seem to be changing as we get into this idea of air leakage into the home. So make sure that all of them are done consistently and that they're done in a way that makes it watertight and airtight. And you can always check with the manufacturer's instructions to find out what they recommend. The next part of the process is the sill pan. This is a major important component that will waterproof the bottom 6 inches of this rough opening. There's a number of ways to do it, whether that's with straight flashing, pre-formed flashing, or also a flex wrap that will flex in place, or you might see pre-formed corners used with a straight flashing. Any of those will work. The bottom line is we're trying to create a waterproof situation here. In case we get a leak in this window, we won't have problems with rot in our framing. And if a window is going to leak, it will be in this area right down here. We need to seal the window in place as we're setting it to the wall. We will do this with a silicone caulk, and that will be put on the flange or right on the rough opening. When those two meet, that's going to give us our first seal of that window flange to the wall. Placement of that caulk is really critical. The flange on this window is about 1 inch wide, so keep in mind that we've taken 1/4 inch away from that inch. We've got about 3/4 of an inch to hit with a solid bead of caulk all the way around, and so that caulk needs to be very precise, a nice solid bead. And one thing to mention is you should never see any caulk on this bottom edge of the window down here. We're always trying to think of letting water out and not trapping it in. If we caulk this bottom flange down here, we would surely trap any water in now that we've created our waterproof sill pan, and that will only cause problems with rot in our framing. So now it's time to talk about a drainage plane, and we're trying to create a drainage plane when we install any window. This is a simple concept we use a lot in building, and it means that any of our upper parts overlap all of our lower parts, and that continues from top to bottom. This window installation is no exception. I've got a top flap of house wrap that is over my head flashing. My head flashing overlaps my side flashings on both sides. My side flashings overlap my sill pan, and my sill pan overlaps my house wrap. If I get any water on this building, it will run over all of these parts, and this overlap keeps us from trapping any water inside of this space. With that idea of drainage plane in mind, we can talk about our flashing, and these flashings should only be on the sides, that's our side flashings, and then our top, our head flashing. You should not have a flashing piece on the bottom. Like our caulk, we want to leave this open in case we get any water trapped in here. It still has a way to escape. So these side flashings, this is a 6-inch piece of bitumen straight flashing. These need to be rolled or pressure applied. They should be using a specific tool that's a roller, and this allows a lot more pressure on these surfaces than you can do by hand. If you show up on site, and I've seen this, where you can see a whole house where this stuff is peeling off, you can be sure that something wasn't done right. And if this fails, then we have lost half of our sealing capability of this whole window installation. And a window that leaks is no good. So keep in mind, this should be nice and flat, no creases or wrinkles, no way for water to get in, fully adhered, and it should look good. This should be a nice, neat installation. Same for our top flashing, and most information will tell you to overlap your head flashing an inch more or further on the left and the right. That's a pretty typical spec. When it comes down to the final step, there is a house wrap flap here that's folded down over this whole assembly, and you will have a sealing tape on each one of these angled pieces. What you should not see is a continuous taping of this house wrap here. What you might see is what's called skip taping. They might recommend to have several short pieces of tape to hold this flap down, but keep in mind, just like down here, we want to make sure that that drainage plane allows any water out from this top flap. We don't want to trap any water up here by sealing this up. One of the last steps of a proper window installation is filling that gap that we created when we centered that window in our rough opening. If you remember, we had a 1/4 inch gap all the way around, and now we have an opportunity with that even gap all the way around to fill it with a material that will insulate it and keep air from passing through there. A good product to use would be a minimal expanding polyurethane foam. This will fill that gap without a lot of expansion. Make sure that the product used is not a high pressure foam or a latex foam. This can cause undue pressure on the frame of the window. It can cause warpage and problems with that window working. And one thing to consider is this might not happen or might not be done by the window installation crew. It could be done when the house is insulated on the inside, but it's very important that it happens in the process to create that energy efficient, leak-free window. And one other option you might see is fiberglass batting that is packed into that gap. It is not as easy and convenient, and it's a little harder to do right, but that is also an acceptable option that a lot of manufacturers actually will recommend. So that's all the steps of window installation. If you're a building professional, say a project manager or a soon-to-be project manager, keep in mind that there's a lot of steps here, and all of them sort of fall on your shoulders. They need to be checked and verified all along the way. Keep in mind the sizing of the rough opening, the sizing of the window, the trueness of the rough opening and how important that is. Also keep in mind all of the sealing steps, from the house wrap and how that gets cut, to the caulking of the window, the sill pan to protect that bottom part of the rough opening, the flashings that help seal it up, and the final step of how that house wrap at the end will fold over. Also, don't forget your drainage plane and how all that works from top to bottom. So I hope this makes sense. Good luck in the field, and keep all this in mind when you check your windows. This video is a production of Trade Skills U, all rights reserved.